Hi there, I'm James from Critical Section, and today we're going to be doing a Q&A around Rust, safety critical, and embedded systems. Thanks for joining us today during the all-online version of Embedded World. So we're going to be answering questions about what embedded Rust is, how can it apply to your industry, and what Ferrous is. So at Critical Section, we're working on a product called Ferrous, which is an effort towards bringing the Rust programming language into safety and mission critical fields, including areas like automotive, avionics, medical devices, industrial uses, as well as high reliability systems in the network and infrastructure industries. Today, I'm going to be joined by Florian, also from Critical Section, who's going to be assisting me. Florian, do you want to introduce yourself?
Hello, everyone. I'm Florian, also part of Critical Section. I'm part of the Rust project for quite a while, and it's a huge pleasure to actually present Ferrous to the world because I think it's the next step in that this language needs to take. I'm happy to be part of it, and you've been sending us questions before this Q&A, and I'll be the question haver for this Q&A. Shall we get started?
Yep, I'm ready when you are. And
Okay.
feel free, if you're in the audience, to ask any more questions in our YouTube chat. We are starting a little earlier than we planned, so feel free to put any questions there. We're going to be working through the questions we have, and we'll keep an eye on the chat in case there are any additional questions.
Thank you. So first of all, thank you for all the great questions because they give us a lot of interesting points to address. And so thanks to everyone who's taking part. And I'd like to get started with the first one as an outsider question. I'm just going to read it out aloud. As an outsider, I've seen Rust evolving a lot over the last years, which by itself is a good thing, but perceived as a significant risk by companies since it brings significant effort in maintenance and personnel. What is your experience in this area? Also, a very critical topic for safety critical systems is the availability of safety certified tooling such as compilers. And for testing, unit integration testing, do you see any efforts there that might be open source? Very few companies will buy into vendor lock with a new technology.
Yeah, that's a lot of really good questions. So the first one around stability. So Rust is a language somewhat unlike other compiled languages that you might be familiar with, in that Rust has a new release of the compiler every 6 weeks. So every 6 weeks there can be potentially new features added. However, these releases every 6 weeks are part of Rust's stability guarantee. So once Rust ships a stable feature, that feature is guaranteed to work on all future versions of the compiler. The only little asterisk there is if there is a bug that is a problem with the language, so it allows you to do unsafe things that weren't really designed. Not just, oops, we didn't see it being used that way, but, oh, this contradicts some other safety guarantee that we have. So one of the really cool things is that you can take Rust code that was written in 2015 for the very first release of the Rust compiler, and it will compile totally fine in today's stable version of the compiler. So although Rust is always introducing new potential features, that doesn't necessarily mean that you need those features, which means you can continue writing Rust as part of your stable development workflow as you go. Additionally, Rust has some really cool mechanisms that allow you to take libraries that were written at different times. So Rust has this concept of additions, which is kind of like the difference between C++ 11, 14, and 17. And rather than making you choose one for your whole project, one library can choose one version and another library can choose another version, which means if you put a lot of effort into qualifying and building and testing a version of your code for a specific version of the compiler, you can continue using that code without any modifications, even if your application uses a newer version of Rust. So Rust has taken a really good blend of being able to move forward and use new features when you need to, but still rely on libraries that existed and compiled and work out of the box. In terms of deliverables for safety critical efforts, that's exactly what Ferrous is. So Ferrous is made up of folks from Ferrous Systems and Critical Section GmbH who have been working on the Rust compiler as part of the Rust project, so the open source Rust project, for a number of years now. And while the open source Rust project is aimed at addressing needs very wide, everyone from consumer devices to backend services to command line applications, we know that the safety and mission critical industries have a really specific set of needs that are not generally applicable to the entire ecosystem. So Ferrocene is aimed at being an effort to prepare those pre-qualified tool chains or certification artifacts that you may need if you're in a medical or automotive or avionics sort of test field, and you need to have a higher level of reliability or some level of traceability or complete packaging that you need for your actual product in these markets. In terms of the areas around testing, and I think there were some other questions around tooling, I'm guessing that includes things like code coverage tools or traceability analysis and things like that. We definitely see that as being part of the Ferrocene effort, because we know that these industries don't just need the programming language and the compiler, they need all the pieces that come along with that. So we're working with that as either part of our Ferrocene shipment or for our partners that plan to integrate Ferrocene, for example, into existing compiler tool chains, that we can make sure that either we or they provide all of that associated tooling that you need. In terms of what will end up being open source and what not, definitely we plan to make parts of the language specification, so the parts that do apply to the upstream Rust project, as part of an open source effort, so as part of the Rust project, or as many parts as we can reasonably to include upstream where it makes sense and we're not adding extra effort for them to support, we do plan on making those upstream. So Florian, I think I answered all the questions in there. Is there any part of it that I missed?
There's a particular question around vendor lock-in, how that is addressed.
Definitely. That's another really good question. So we definitely agree with what you said, is that particularly for new company or for new technologies, companies really don't like having a single vendor for that. And that's why Ferrous Systems is focusing on the Rust language side of things. So the front end of the compiler in particular, but also the language itself. And we're planning on working with a number of compiler backend providers so that you have the choice of, depending on what level of criticality you need for your industry and your application, you may be able to use the existing LLVM backend. You may be able to use an existing safety critical qualified compiler backend that allows you to use a number of different backends so that you have more than one choice of supplier. And as we mentioned, we're making these efforts towards specifying the language a part of the open source initiative. So if there are other companies in the future who are able to provide similarly qualified front end or language components, that's a possibility for them as well. So we definitely see this as de-risking the single vendor problem, either from the language perspective by keeping it as part of the open source project, where all of these artifacts are in the open and you're not locked into one vendor, or by working with multiple backend vendors so that we can support all of the different industries that have a particular different need for their operational environments.
Perfect. Thank you. This also flows nicely into the next question that is very direct around the open source parts. So someone asked, with Ferrocene, how much of the work will be open source or freely available? In particularly, will the spec and verification suite be available to other projects like GCC RS or mrust-c to use freely? For those that are not that used to Rust, GCC RS is the effort of bringing Rust to the GCC compiler collection, and mrust-c is an already existing alternative Rust compiler that is written in C that is particularly used to bootstrap the Rust compiler, which is written in Rust, on new platforms.
Yeah, definitely. So for those who, yeah, definitely. And right now, Rust is primarily based on LLVM. So similar to Clang or Swift, if you've used those languages, they're based on the same compiler backend. So the part of the compiler that does optimizations and generates code for all the different platforms that you're working on, whether that's ARM or x86 or RISC-V. And the answer is we're definitely collaborating with the upstream Rust project. I see a specification of the Rust language or specification of components of the Rust language as being something that has the most value when it's out in the open so that everyone can see it, and that people working on the open source Rust compiler have access to it and have abilities to test against that. So likely the specification will be entirely within the scope of the Rust project. So those are all artifacts that anything that we're able to specify and do all of the work on preparing that for safety critical usage, that is a resource that will be available to other folks. We also see a component of the verification efforts for that, at least as far as is necessary to verify that the compiler is compliant with this, as being something that also has a lot of value of being out in the open. There may be some verification steps that are necessary for the last mile of safety critical qualification for these specific targets. So when you're trying to use the Rust compiler at a specific qualification level for example, the automotive industry, let's say you are targeting ASIL B, for example, all of those artifacts and deliverables that may be necessary to provide that as a pre-qualified output, all of those may not be part of the open source deliverables. Those may be part of the qualification package that are provided as part of the product. But definitely with regards to the language and how Rust the language relates to a higher level of reliability or a higher level of qualification readiness, we definitely see a huge portion of that as being most useful in the open source deliverables. And we see those as really either living with the Rust project itself or living very close to the Rust project itself.
Nice. Thank you. Continuing on the topic of tooling, from a different direction, how much work is going into integrating Rust with existing tooling used in the industry? Particularly, the person asks, when I was in safety critical, we leaned a lot on VectorCast and Polyspace code provers Polyspace code prover for numerous projects.
Yeah. So we're definitely aware. I'm not sure of anyone public, unfortunately, so I'm not sure I can provide too many details here. But we've certainly talked with some folks who are already in the safety critical world, who are looking at what it would take to integrate Rust, and we've helped some of them integrate Rust as an initial work. In terms of VectorCast, in terms of tools that help you generate unit tests or generate code coverage or validate your tests are complete and things like that, those are definitely things that I could see coming in the future, and that as Critical Section, we would love to help those companies out in their journey with Rust. So the answer is we've started some conversations around that, and it's definitely an area that we plan to focus on while we get closer to our initial delivery in the end of 2022 of what kind of tooling suites need to come along, and where that tooling can either be repurposed from existing tools that support C and C++. For example, Rust and C and C++ work very similarly in a lot of ways, and often it's not too much effort to teach a tool a little bit more about Rust and get a lot of benefit out of that. So those are definitely things that we're interested in doing. And if you are a company that provides those kind of tools, whether it's unit testing or code coverage or code analysis and observation tools, those are definitely things that we're already talking to folks, and we definitely would love to talk to more folks about having a really integrated solution at the time of our launch of how to support Rust as a first-class language option in all of these tools, because we really see this as being a need to not just have one company providing these solutions, but really moving the whole safety critical industry towards providing solutions around the Rust language so that all of the end users and all of these tooling providers can get the maximum benefit from them. So it's definitely something we have an eye on, and we're already starting conversations about, and we hope to share more as we get a little bit closer towards our initial release date, which is planned around the end of 2022 right now.
Yeah, I'll quickly add one thing to that. The integration into these proprietary tools is mechanically not very different from open source tooling. So you can see a lot of these efforts already about projects like GDB and other projects that already support Rust. I'll move on to the next question, which is hardware related, or more hardware related. Working with porting GCC and LLVM for proprietary processes in the automotive field, we are faced with a question on how to certify the output of the tools. Certifying these compilers being a bit complex, the fallback is to execute a big test suite to give confidence. How is it going to be handled with Rust? There's no ISO standard yet as a reference, and I guess no exhaustive test suite. So do we address that?
Yeah, that's really you've distilled the whole challenge of Ferrocene down into one question. So, very, very well asked. I will say, from a lot of perspectives. So, on one hand, what is required to use a compiler or the outputs of a compiler varies really wildly based on what industry you're in. For example, automotive has one standard that they use, or at least a set of expectations. Sometimes it's not always encoded into a formal standard or a formal request. Avionics might be different. Medical may be different. So one of those things that's always a challenge is how do we address the needs and the expectations of the different industries? In particular around Rust and the Ferrocene effort, one of the things that we aim to do is to aim towards language specifications that have moved beyond sort of the more traditional ISO spec that is a PDF that describes what the language should and shouldn't do, and to try and capture that, at least when possible, into a more machine understandable sort of specification. So specifying how aspects of the language work, for example, the type system, or what kind of guarantees do certain aspects of the language provide or not provide, and to work these down into sort of a more runnable specification where we can do things like formal analysis, where it makes sense to do formal analysis. Where it doesn't make sense to do formal analysis, we can rely on things like exhaustive testing or areas of testing of the specification itself to make sure that it's consistent and doesn't leave any holes or isn't inconclusive in its description. And then working on that to bring those specifications down to the compiler and test suite itself. Another thing that we aim to do is to sort of split this qualification process into two big pieces. One piece of that being really just understanding the Rust language and how the Rust compiler understands that. So we'll typically call that from the Rust translation from Rust source code to some sort of intermediate representation where we can set a certain set of rules that say when you write Rust syntax like this, the compiler understands it like this. And from there, splitting that into the piece where we then translate that intermediate representation into the actual executable code that is translated for your actual binary. Now, some industries are really worried about that executable code translation, and some are more focused at what the language specifies and things like that. And by splitting this up into two parts, one, we sort of split our problem into two main parts, which gives us a good middle point to do verification on, and making it a little easier to specify and validate those two different parts, and also allowing us to rely on existing qualified compiler backends and things like that for industries that already have existing compiler backends. So, for example, taking the Rust language, making sure that it's consistent, and then translating that into a compiler backend that already has been qualified for translation to targets like ARM or x86 or Infineon Tricore, for example, or PowerPC-based targets, those kind of things. So we definitely plan to split this up into two parts as one main concept here. The other is to take work that's gone into languages like WebAssembly, which has come around in the last couple of years in terms of setting a different bar of how you specify a programming language, particularly one that may be applied in different environments and things like that. Like we definitely will have in embedded. And then reusing as many pieces as we possibly can. So if we can partner with people who have already qualified parts of a compiler, if we can shorten the total distance there by relying on their existing qualified outputs and focusing on a smaller piece of the compiler to validate. So I could really spend a lot more than the rest of this Q&A session on that, because this is really exactly the kind of problem that we're focusing on Ferrocene. But I'm happy to, if there are any follow-up questions in the chat, I'm happy to do that. But yeah, we're looking to really apply the best that research and engineering has to provide of how people have learned about specifying a programming language over the last 10 or 20 years. And then taking a really good pragmatic balance of what can we lean on in terms of formal verification and what can we lean on in terms of manual or automated verification for our actual end use, and figuring out a good, healthy balance of how much can we offload to a machine, how much can we partially offload to a machine, and then what do we really need to do in terms of manual verification to make sure that we can ship this repeatably and on a much more regular schedule than you might be used to for a safety critical compiler distribution. Did I get everything in that, Florian?
Yes, I think so. There's
okay, good.
Again, there's one thing that I would like to add from the conversations that we had with industry partners was that Rust, the current Rust open source project already has a pretty extensive test suite, and especially a lot of documentation through the RFC process, which does already at least give you the groundwork for all the things that we want to do. Yeah, so it's a good position to start in. So now that brings us to a question that is actually 4 questions. So we go one by one. The first is a very direct one. Rust is a very complex and still evolving language. And you already touched on a number of points in the last answer. The direct question is, what effort will be needed to document a snapshot?
Yeah, this is definitely one of those things that a couple people have asked about, because Rust is a language that does add new features over time. Probably something important to describe as background is the way that Rust actually delivers on these stability guarantees. So even though the Rust compiler ships a new stable version every 6 weeks, it has what's called a release train. And this release train means that there's always a stable version of the Rust compiler, there's always a beta version of the Rust compiler, and there's always a nightly version of the Rust compiler. Now, the nightly version has every feature that anyone has implemented or partially implemented or is on their process of implementing. And this is mainly used for people who are developing the Rust compiler itself or making sure that their systems work on the potential features that are coming down the line. So the way the Rust release process works is that pretty much at any time, anything that's been accepted for a merge into the Rust language is going to live in the nightly version of the compiler. And these can be features that come and go or might change really drastically over the lifetime of their implementation. But that's sort of where we want them. We want to be able to play with them. We want to be able to try out these new features. We want to try them on existing code bases to make sure that they don't interact in unexpected ways. But for a feature to move from the nightly train to the beta train requires an explicit approval and review step. And so this is a stabilization process. So the features that actually get promoted from nightly to beta are only features that we really have confidence that they will probably look like this if nothing goes wrong when they're actually shipped as part of the stable version of the compiler, which means that they've already been iterated on. We're pretty close to a final design, but we want to push these changes out for sort of one last check to the ecosystem and the users to make sure that this feature is going to work as it's been designed. So again, this is a point where a feature's already been completely designed, completely documented, and completely tested, and is pretty much ready for stable. When a feature is promoted from nightly to beta, it then, in the next beta release, will be made as available there. And these beta releases typically get released around the same time as the stable releases. Sometimes you might have a couple beta releases within a single 6-week period. but every feature is required to sort of bake in the beta release for at least 6 weeks before it gets promoted to the stable release. Now, an important thing to note is Rust stability guarantees only apply to the stable branch of the compiler, which means that Rust stability guarantees really only apply to anything that has landed there. So you always have the chance to pull something out of nightly if it's not ready to go, and you always have the chance to pull something out of beta last minute if you find that it's not ready to go. Now, the reason that I explain this as part of the background is Rust already sort of has a pipeline of dealing with features that have an incremental level of stability, where the compiler can already sort of handle different versions of these implementations and making sure that only the stable ones make it into a release that are ready to be supported for a very long time. Now, at least with our initial plan, we plan to extend that metaphor a little bit as part of the Ferrous releases. We see the specified version of the Rust language, or a fully critically specified version of the Rust language, as something that can be analogous to the stable version of Rust. So something that can sort of be a even more stable release of the Rust compiler. Now, how often this releases, whether it's every 6 weeks or 3 months or 6 months or whatever interval, is something that we're still working on. But the idea would be that we'd introduce a similar train for a critical or specified version of the Rust language, so that our safety critical or mission critical customers could always use the stable branch of Rust as sort of a development target. But when they're actually looking to pick a version of the Rust compiler for shipping their product, something that is likely to have a long-term support guarantee for a very long amount of time, something that's likely to be field and integration tested and have all the paperwork prepared for it, whether you're shipping an automotive or an industrial or an avionics sort of product, that you can choose one of the releases from the specified, or one of the releases that are provided by the Ferrous effort itself. Now, we also see that being, like you said, as a subset of the language, the part that has actually had the full language specification and validation and verification efforts, and in many cases documentation and traceability efforts also applied to it. But we don't see this as being something that really needs a huge difference in how Rust already handles the difference between nightly, beta, and stable, in that you can choose the pipeline that is applicable to you and your releases. And if you try and use a feature that only exists in the next level up, so for example, if you were using stable and you tried to use a beta or a nightly feature, the compiler would rightly give you a compiler error. Same if you were using the qualified version of Rust. If you tried to use a feature that wasn't in the qualified version of Rust, only in the stable or the beta or the nightly, then again, you would get a compiler warning that says, hey, you're trying to use a version, or you're trying to use a feature that comes with the language that's not part of the release train that you're currently on, and helpfully give you a diagnostic. And this is one of those ways that we can make sure that our end users are only using a well-specified subset of the language that has been verified and validated, and that we have these kinds of reliability expectations and guarantees around. So really, again, we're trying to learn from how the Rust project has learned to provide stable guarantees around a rapidly iterating compiler, and to meet the needs of both the developers who are working continuously, as well as the users who are on a slightly slower release process, and to provide the best of both worlds in those regards. So I think that was the first question. Do we want to move on to the second question in that batch?
Yeah. I think it's also a good moment to highlight that a lot of different organizations have a lot of different requirements on the speed of the language evolution. And there have definitely been organizations that have voiced that they actually would like to switch their compilers, like update their compilers and their language versions more often than they currently can. So that is something that we can take into account. The next question is again about tooling. How about selecting a small set of key crates and tools for the embedded space? For example, highlighting the names heaped loss and probe RS. Just again, for those that are not used to the Rust space, Rust refers to libraries as crates. They're their own code shipping units and also a binary format. So this is essentially a question around library stability and guarantees.
Yeah, that's a really good question. So Rust is not so different from any other language like C or C++, particularly in the safety critical industry, in that if you're using a library component, you're responsible for it. So just because it's someone else's code doesn't mean that you get to say, oh, I don't have to verify it, or it's not my fault if something goes wrong. We know that in the safety critical industry, you're responsible for all the components that you ship. Now, the two ways that these typically get addressed in industry today is by either bringing them in-house and doing the qualification work yourself. So, for example, if there was a safety or an open source library that you wanted to use, you need to do all of these specification and verification and validation to make sure that these libraries fit into your workflow. Another option would be to use libraries that are pre-qualified by a certain vendor. So a lot of people use pre-qualified operating systems or libraries that come with operating systems as part of their ecosystem. This is definitely something that we're looking to as part of Ferrous, because we think that just Rust, the language by itself, is a really big step forward. But one of the nice things about Rust is that it doesn't require you to reinvent the world all of the time. This means that you can reuse your code in really powerful ways by using the abstractions that Rust provides and by using libraries and crates, as they're called, as well as tools that exist in the Rust ecosystem as part of your whole solution. Now, Rust does have an upstream package manager called crates.io. However, if you are looking to use these libraries in a safety critical context, you probably want to make sure that you're only using libraries that are suitable for your end application. And this is something that we're looking to do as part of Ferrous Systems, either taking existing open source tools and working with the maintainers of those tools so that we can have a fully documented and qualified version of that. Oh, excuse me one second. A fully qualified version of those libraries, or to write versions of those libraries or versions of libraries that are applicable to safety critical spaces for doing things like logging or doing things like providing data structures or sending messages over a network or something like that, where it's not necessary to re-implement all of these from scratch. These would be providable either as a supported library from Ferrous Systems or as a service that Ferrous Systems or Critical Section could provide as a code review service where we've done the due diligence and testing and specification that's necessary to use these in specific industries, where we'd be able to have a version of a package manager where you can say, I only want to be able to use ASIL-B appropriate libraries, and could make sure that all of your dependencies met those kind of expectations. So this is definitely something that's come up very often from our customers, especially ones that have already started using Rust and really like the ability to reuse code and really like the ability to use third-party code from the ecosystems in their applications. And we want to extend that capability to safety critical areas or mission critical areas as well. So I think that's everything, Florian.
Thank you. I think this flows nicely into the next question. There's also the question about what do we do with libraries that, for example, are built in the ecosystem, especially around their maintenance. So the question is, if such a set were selected, how would quality, consistency of the dependency tree, and long-term maintenance be ensured? For example, including project management and financing.
Yeah, so for libraries that are really critical, what I would see is likely there being for anything that's required. So for any low-level libraries that are necessary for getting Rust working on a target like Cortex-M or Cortex-R or Cortex-A, I would definitely see the existing library ecosystem components being a really excellent starting place. I could definitely see a company like Ferrous picking that up and providing feedback to those really core infrastructural libraries so that we're not duplicating that effort. And if there really is a necessary need to to ship a version of this, why not provide that to the ecosystem as well? Perhaps not the the paperwork that's really required for using them, but there's no need for the open source ecosystem and the safety critical industry to duplicate those efforts, because that just really is a lot of duplicated effort with not a lot of value. So what I'd probably, this is mostly a guess at this point, because this is definitely getting much further down the road to where we have a parallel open source, more consumer or hobbyist oriented open source ecosystem, and a parallel safety or industrial critical use case. What I'd probably say is making the open source project sort of the authority with the ability to also verify that is probably the best of both worlds in my mind. Rust already has a really good way of observing your dependencies and seeing what version they are and really constraining them to specific versions, going all the way to making sure that the contents of the library that you're compiling matches what your expectations are in the form of cryptographic signatures and things like that. And the ability to specify dependencies, whether they come from a public package manager or a private package manager or internal folder or version control dependencies, where it's really possible to say, this is my exact chain of dependencies, and to be able to track that in a version control system or a document management system that allows you to say, yes, we have specifically validated these versions of these libraries and we're comfortable using those. This is something that can be audited as part of your release cycle, or can be checked continuously to make sure that these things don't change accidentally over time. So as I mentioned before, any dependencies that you pull in will need to be verified by someone. So this could either be done in-house as part of your efforts, or it could be done through a third-party provider like Ferrous Systems or Critical Section as part of an offering as part of the Ferrocene toolchain, or additional services on top of that. So what I would say is Rust already provides the tools for seeing what you have and whether they're expected versus what you need. And then Ferrocene aims to augment that by making sure that you have the building blocks you need, depending on which ecosystem you're working in, whether it's consumer or hobbyist level tools, or whether it's industrial or safety critical or mission critical tooling, and then making sure that there's as little duplication as possible, because if we can have the whole, non-safety critical industry and safety critical industry using the same building blocks, that means it's going to be much easier to move components from one way to the other in the future. And we should hopefully experience much less fragmentation in all embedded industries that are using Rust, whether they're safety critical or not.
Perfect. Thank you. I would like to actually also highlight a chance there. If, for example, an open source maintainer agrees that they would really like to bring their library up to that level, that means this library will also continue to be available to the public at the same quality level. Oh, James is gone. Whoops.
Clicked a couple wrong buttons there. I am back. So I think we have 2 more questions in this 4-question series.
Exactly. No, that we have 1 more.
Okay.
Which also ties into that. Would professional reviews have to be paid, or what contribution do you expect? Or can plan managed by volunteers in the community? What would be the interaction between community and professionally organized and sponsored activities be?
Yeah. So this is one of those challenging questions because it reaches much further than safety critical and goes much more into funding of open source contributions and things like that. So I definitely think the people who there's a lot of work that goes into qualifying a library for use in safety critical systems in terms of review and in terms of what you're looking for and how you document things and things like that. I definitely think that the people who are doing the, I don't want to say boring, but the much more narrowly applicable work, like documentation and validation that are relevant to these industries, should be the ones that are being paid for this, should be the ones that are doing that. So in terms of what I think Critical Section will do in terms of working towards this is likely to volunteer as maintainers of this and to give our efforts in and make sure that that the people who are selling the qualified versions of these libraries are the ones who are doing that work to keep that up to date and maintained, and not put additional work on open source maintainers and maybe things that people are building as part of their hobby or part of side work or even as part of their job, but as a limited scope to the specific industry that they're working in. So I think that the correct answer in this space is to either work with these companies if they're set up to do contracting, and make sure that we're making sure that these libraries are up to the level of quality that they need to be, and to be doing the sort of final check of reviewing if these are companies that are already working in the safety critical space. If these are individuals or companies that are not working in the safety critical space, we'd probably approach them and figure out how we could maintain this in a way that doesn't slow them down, but also means that we can either provide a compatible version of this library or shoulder that burden of maintenance. Because I definitely think from a project management and a documentation and a release management perspective, I think the weight of that work really needs to sit on the people who benefit from it, whether it's the end companies that are using these libraries or whether it's a company that's helping to make sure that these libraries are up to the level of quality that they need to be for the particular application that they're being used for. So it's one of those tricky things. I don't think I can give a one-size-fit-all answer, but both Critical Section and Ferrous Systems is an open source first company, are open source first companies, and I think that really shows through our work with the Rust compiler project in figuring out what makes sense to do the work because we are extending something that exists into a new market that has slightly different requirements, and what we can make available as part of the open source offerings that benefit everyone. So I think probably looking at the same kind of strategy and approach that we would with the open source Rust compiler itself, to extend with all of the different libraries that are out there in the ecosystem, whether they're data structure libraries like you mentioned with Heapless, or whether they're tooling libraries like you mentioned with ProbeRS that are useful for debugging and analysis of tools in the field.
Thank you. So let's switch gears again quickly to the language level. The next question is, will you restrict the number of allowed language features or syntactic sugar for safety critical usage of Rust? What about unsafe code blocks?
Yeah, so this is one of those challenges of what is necessary to run Rust. Okay, so let me restart the answer to that one again. So the answer is ideally we'd like to include as much of the language as is possible. So as much of the language that is possible to include within the specification and can be specified. Whether syntactic sugar should or not be included. So syntactical sugar, for those who aren't familiar with, are usually a way of the compiler automatically doing something for you. And the answer is, if we can specify those behaviors and we can have confidence in those behaviors, why not include them as the part of the version that gets qualified as part of the Ferrocene efforts? The answer is, not everything may be included at first. If there are items that are a big challenge to properly specify or properly validate, and they're not strictly required, they'd be nice to have, they may not end up in the initial version of the qualified compiler offering. However, I would love for long term for essentially the qualified version of the compiler to always be converging on the current stable version of the Rust compiler. So ideally we don't have this divergent path between the safety critical version and the upstream Rust project, but rather just being an iterative approach at properly specifying the, more bleeding edge or rapidly moving version of the stable compiler. And the stable version of Rust is by no means bleeding edge, but comparatively to a fully specified and qualified and tested version of it, you see this a lot in the industry currently already, in that GCC or Clang will ship a version of C++ 21, for example. And then usually these are available in safety critical tool chains 6, 9, 12 months later after there's been a chance to qualify these features. And I see, a release train that targets the safety critical market being exactly the same. Now, around unsafe. Unsafe is a really interesting thing in Rust, in that Rust has some really strong guarantees about things like memory safety and freedom from certain possible bug categories if you use only the safe version of the Rust language. Now, what's interesting about the safe versus unsafe version of the Rust language is that the rules don't actually change between the safe and unsafe version of the Rust language. The only difference is in unsafe mode, you as a programmer are required to manually verify that you have upheld all of Rust's safety guarantees. Now, in the safe version of Rust, the compiler will automatically do all of that for you, which is why a lot of us really like using Rust, because the compiler will tell us ahead of time if we've accidentally done something that may not be correct. Now, how we handle this for the safety critical version of the language, we're not 100% sure about yet. The answer is likely going to be a mix of what we can verify or not verify automatically, we will. So if we can have a static analysis tool or a compiler tool that allows us to say, yes, we can see that the unsafe code that you just used is correct, or is correct given a couple preconditions, then we may be able to automate or reduce the manual effort. However, even if we say, here is the 54-item checklist that you need to make sure manually as a human is correct before or any time you use unsafe, we find that this still does provide value because it scopes the amount of manual verification work required to a much smaller footprint, which is very much a reasonable thing to do in safety critical projects, where you can say, okay, well, I've got a 50,000 line of code project, but only 500 or 1,000 of those lines are unsafe. We can spend a lot of effort and manual verification or automated testing and verification of these 500 or 1,000 lines, and we can reduce the amount of due diligence that we have to do for the other 49,500 or 49,000 lines of code, which is still a net benefit versus other languages like C or C++, where these memory safety bugs can pop up anywhere in that code, because C and C++ are memory unsafe languages, which means you still have a net gain of verification effort and validation effort that goes into this, even if we do sort of our worst case expectation at this point, which is to provide a review checklist for those points and sort of punt to manual verification or review verification. And in that case, we would document those expectations as part of what are called integration requirements for our tool chain, which would say if you use this tool chain, you're allowed to use it like this in safe mode. And anywhere you have an unsafe block, please either use this automated tool, which lets you help verify that. And for anything the tool says, I'm not sure how to validate this, we fall back on a manual review checklist of things like that. Or at least that's our current plan. Perhaps we may be able to do even better than that, but that's currently what we see as our worst case scenario at this point, which, as someone who's worked in the safety critical industry, still seems like a huge improvement of where I need to be doing my reviewing and due diligence.
Thank you. We've been going for roughly an hour. We still have two very interesting questions left, but I would like to give you a voice 5 minutes of pause. So we'll be seeing you back here in roughly 5 past. Thank you.
Okay. Yeah, and definitely feel free to ask your questions in the chat. If you're just joining now, as I can see some people did, we did start about an hour early. This will be available for... This will be recorded and will be available immediately, so you can go back and watch the questions that we had submitted beforehand. But any questions that are asked on YouTube now, we will answer in the chat afterwards. So if you're just joining now, this is a perfect time to be able to ask your questions, and you'll be able to go back and watch our answers to previous questions after this session. So, yep, like Florian said, we'll be back in about 5 minutes.
And we're back. We've got two more questions that were asked before, which I'd like to cover, and then we have a number of questions in the chat. Let's start with a smaller one. There was a question, which platforms target triples are planned to be supported? And I guess this is less about an exhaustive list, but generally, is there support for targets that are not currently supported yet?
Yeah, so Rust as a language already supports a lot of different platforms and environments, or target triples, as they're called in LLVM or Rust terminology. These are different targets like ARM thumb targets or ARM64 targets or PowerPC big endian or PowerPC little endian, and on all different operating environments like Linux or proprietary compilers or operating systems, or not compilers, proprietary operating systems and things like that. So Rust already has a large number of support for targets, including most of the common ARM targets, including ARM Cortex-A, R, and M. Also a number of PowerPC targets, and of course x86 and x86-64, as well as newer targets like RISC-V in a variety of different configurations. In terms of which will be supported for the safety critical release, so a Ferrous release of the Rust compiler, that really comes down to the interest of our customers. So we know different industries have a lot of potential different interests. Some of them are moving towards processors like the ARM Cortex-A or the ARM Cortex-R, particularly in time-critical systems. I also know that there are a lot of companies working with platforms that aren't currently supported by Rust or LLVM, like Infineon Tricore is one that I mentioned that I know is really pervasive in the automotive industry. And the answer to that is, for a version that's based on the LLVM target, or an LLVM-based version of Rust, I think it's very likely that we could see popular targets like ARM or RISC-V supported in this space. But we're also working with, as I mentioned, different compilers' backends. So the ability to potentially use a compiler backend that already has support for example, Infineon Tricore could definitely be a possibility. I'd say which ones are likely to be supported in the first release or two? Probably the ones that partner with us and have expressed an interest in these specific targets. So we're definitely going to be working to support the customers that we have. In the long term, we hope to support all of these platforms with a qualified version of the compiler. But just because there's a lot of work to specify and qualify a compiler for a specific target in a particular environment, whether that's automotive or industrial, there's a lot of work that goes into that. So we're likely going to be focusing our efforts on areas where there are customer interest in. So we've already talked to a couple, some that have expressed interest in ARM targets, some that have expressed interest in more classical targets like Infineon Tricore, as well as brand new targets like RISC-V. So the answer is, if you have a company that's interested in having a supported toolchain in Rust, even if you're not sure if you're going to be using Rust just yet, definitely get in contact with us, because we are keeping an eye on all of the interest that has been expressed to us, and that will probably guide which targets are going to be part of that initial release. But in the long term, we hope to support as many platforms as is reasonably possible. So if you haven't had a chance, feel free to reach out. Florian's going to know our best contact email to get in touch for platform support and more information regarding that from the critical section side of things.
Thank you. I'll post that in a second. So the last question, this is a pretty interesting one. Just imagine if you had a new customer that was about to make tech decisions for the next decade, would you recommend or at least consider Rust for embedded devices at this point? The person was also giving us some constraints to think in to make that easier. I'm thinking about bare metal RTOS usage that is field bus heavy and has no safety requirements, but potentially may have in the future. Targets would be the usual suspects, M4, Cortex-A. The field bus bit could prove to be annoying, as there are no native crates available yet. Again, crates are Rust version of libraries. So kind of a I want to design something here question.
Yeah, I think this hits on a lot of really good targets, and thankfully, this question asker constrained the question enough that I don't have to give the very boring engineering answer of it depends. I would say if you're planning a technology for the next 10 years, I think not looking at Rust would be doing yourself a huge disservice. I think what we've seen from the embedded development industry and the even the safety critical industry is that the role and the responsibilities of embedded systems have changed really drastically over the last 5 or 10 years, where there's a much larger expectation of complexity all the way down to bare metal embedded systems. Whether that means running a real-time operating system, whether that means running untrusted applications on your real-time operating system, whether that means running a network stack or being constantly exposed to the network because you have an always on radio or a radio that is continually connecting up to a server, or a need for being able to do in the field software updates. Software has only gotten more complex in the last 5 or 10 years and at a really accelerating rate. And what I've seen from my experience, and this is getting a little editorial at this point, but I'll weigh in since you asked, is that this software has really gotten much more complex in the last couple years, and we're really starting to see the point where C and even C++ don't always give us all the best tools for managing complexity, particularly in resource-constrained systems. And this is something that we saw on the server side 5 or 10 or 15 years ago, where people started switching to other languages, whether it was Java or Python, where they were willing to take some kind of a performance hit to have a better understandable or a better reliable or a memory-safe system. Now, for our embedded systems, unfortunately, we don't have always the luxury of being able to choose an alternative that is maybe less performant, but gives us better safety guarantees. As embedded developers, we sort of have to deliver on both. We need a safe operating environment that can be stable for a very long time and that is as efficient as possible, because we have to keep our manufacturing costs down as well. So, following the trends that I've seen in both consumer as well as safety critical industries, I think C and C++ as a language or as a tool are still at the point where they're very reasonable and possibly one of the more reasonable choices that you can choose for a project today. However, I don't think systems are going to get less complicated over the next 5 years or 10 years. I think they're only going to continue to get more complicated as they introduce things like multi-core microcontrollers, or things like ARM's trust zone, or things like separation of environments between your operating system and your applications, or between privileged areas and non-privileged areas in your application. And you're going to continue to have things like network stacks that are going to be doing more and more and deal with more complexity. So what I would say is, if you're choosing a technology for the next 10 years, I would absolutely make sure Rust is on your evaluation list. And if you haven't already started to evaluate Rust, then I think you absolutely should now or in the next year of your due diligence, because although I can't say that Rust is the perfect answer for everyone starting a project today, I only think the trend is going to expand in the next 5 or 10 years, where C and C++ become less and less suitable for the level of complexity that we expect from our languages, and Rust is only going to get better and better in terms of the drivers and platforms that it supports perfectly out of the box, like it does for some platforms already today. And particularly, as you said, safety critical is not a concern today, but maybe in the future. I think this is the perfect timing to choose Rust as a really strong potential option for your technology stack for the next 10 years, because you're already able to use it in consumer applications. And if your only missing problem is missing libraries and things like that, these are things that can be developed portably in Rust and work on a variety of different systems. Or there are companies out there like Ferrous Systems, which has experience and expertise in developing these libraries and components to specification, and either publishing it as an open source project that can be maintained in the open, either by Ferrous Systems or by yourself, or as part of a proprietary deliverable, depending on the industry and the ecosystem and the applicability of the project that you're using there. So what I would say is, if you're only missing drivers and you don't have to worry about safety critical, Rust is an excellent choice. Not just as something that's relatively new and likely to extend your possibility of using this language not just for the next 10 years, but the next 20 years, but also in terms of developer tooling and speed to market. We really see Rust innovating on being able to get started faster and reuse code components in a much more efficient way that has allowed Ferrous to help our customers to ship faster using Rust. And also having a fairly good story around interoperability with existing components, which means you don't always have to start from scratch from Rust, and means that you can instead incrementally move your stack over towards something that is probably, in my opinion, a better foundation for the next 20 or 30 years versus C or Rust or C or C++, which have been wonderful foundations for the last 10, 20, 30 years, but may not be that same good choice for the next 10, 20, or 30 years.
Thanks for that elaborate and to the point answer. Which brings us to the questions in chat. I'll just go top to bottom. And the first question there is there such a thing as Misra for Rust? Pretty direct.
Yeah, so Misra, or more commonly Misra C or Misra C++, are a set of coding guidelines that are originally developed for the automotive industry, but have also been adopted for a number of different safety critical applications as sort of the reference example of defining a safe subset of a language. So what it aims to say or not say is to say that these portions of the language are reasonable to use, and these portions of the language are not reasonable to use. And they were a really valuable tool because the C specification either doesn't describe some things or describes some things as potentially implementation defined, which means that if you want to maintain portability, especially in predictability of safety critical systems, then it's good to choose a subset of that language that's common to all the different environments that you could possibly be running on that will allow you to make sure that you're shipping a reliable system. Now, I want to kind of attack this question from 2 points. From one perspective, there's a company called Polysync that went through and did an observation of how much of Misra C applies to Rust today. And their analysis really sort of cleanly broke down into basically an even distribution of 3 answers. One of them is, these are points that don't really apply to a programming language. They're more architectural or conceptual. They say things like, make sure your functions aren't too big, or make sure that you have well-named functions, or that they're organized in a fairly reasonable way. And these are more architectural concerns that aren't really going to be different between C or Rust, but definitely are part of a good coding standard guideline, regardless of what language you're working in. Now, of the remaining 2/3, they split into basically half and half, where one half were Rust already prevents these from happening today. So as part of the stable version of the Rust compiler, there are already checks that would mean that these would be compiler errors or would be available as warnings as either part of the compiler or as part of the standard linter, which is called Clippy in Rust, which does some additional warnings and checks that go above and beyond what are just compilation warnings, but also viewing things that, oh, this function is starting to get too large or something like that. So 1/3 of those of the total, or a half of the remaining ones, were already checked by Rust, which means you wouldn't need any additional tooling to check those things today. They're already checkable, or they're already a compiler error in Rust, depending on what category they fall into. The other 1/3 were items that were not currently checked by these tools, at least at the time of this analysis, but could potentially be included as another third-party tool or as extensions to the existing Rust Clippy area. So you can already see Rust is helping in terms of lowering your surface area for things that could go wrong, in that 2/3 of these they basically are a reduction in surface area of what could go wrong. Now, in terms of how this applies to our safety critical industries, of which is where I see Misra typically applied, our goal is actually that the safe version of Rust, so the safe version of the Ferrous shipped version of the Rust compiler, is your safe subset of the Rust language. Now, interestingly, even in ISO 26262, which is the safety standard for the automotive industry, they don't say you must use Misra C. They say you must use a safe subset of the programming language that you use that allows you to make strong guarantees of the programming language itself. They don't say it has to come from a third party. They don't say it has to be specifically Misra. So our hope is that actually the safe, if you don't use the unsafe keyword in the safety critical version of the Rust compiler, that you've met that objective already because you have delivered on a safe subset of the language. So to answer your question is, sort of, we're already meeting most of those goals, and that in the future, we no longer require a third-party tool or specification to meet those goals. Those are just part of the library or part of the compiler that is provided to you. So hopefully that answers your questions.
Thank you. Next question. What can be done to lower the barrier for new users into this field? Are there any plans to have something like the discovery book or more open source resources for the safety critical domain?
Yeah, so for those who aren't familiar with Rust as a programming language or an ecosystem, Rust puts a really strong stress on documentation and teaching and having teaching materials as a really core part of the language and the ecosystem around it. We've kind of said, Rust is a very strict language, and it can be very, mean in how strict it enforces all of these rules that give us that safety that we want. So sort of a trade-off to that is we make sure that there are a lot of good resources, either provided by the compiler itself, giving good warnings, or documentation that exists out in the ecosystem, like the Rust book, which is a print quality book that's provided free online. You can buy a paper version, but you can also go view it online or get a downloadable version in an ebook or a PDF format. And similarly, in the embedded Rust ecosystem, we've also put a lot of effort into teaching as well. There are a couple books provided by the Embedded Working Group, which is the group that's working with the Rust compiler team to make sure that embedded systems are well supported in Rust. I'm one of the members of these teams, particularly the resources team, so this is a little close to home to me, but we make sure that we provide books like the Discovery book, which is meant for people who know Rust already, but are learning embedded systems, or the Embedded Rust book, which is meant for people who already know embedded systems, but are learning embedded Rust. Ferrous Systems has furthered this. Ferrous Systems provides a number of training materials and resources, as well as hands-on tools to learn the Rust programming language and things like that. And this is something that I can see us only furthering through Critical Section and things like that, of having guides that allow you to understand some of these core concepts of Rust, the language, and how it provides these safety guarantees. And also, as we're building this documentation and making people understand how things like this work for the Rust project, also explaining a lot of these concepts around functional safety. So the overarching term that's typically used in these industries is functional safety. And that talks about how you design a system to work the way that you expect and to admit that it can sometimes fail, and that we can try and predict these failures and make sure that we can make them fail in either a safe way or a predictable way. So I definitely think these are things that we don't have as part of our deliverables here, but likely bringing in our culture from the Rust ecosystem. I can't see us not shipping a book that explains this to people that we're working with in the Rust compiler itself, so they understand the kind of guarantees that we're working with. And we see this as just being a great way to make sure that our customers are on the same page as us, and our users are on the same page with us. Because if we don't document it, they've got to figure it out themselves, and they might come away with a different impression than we want. So I can only see us delivering. I don't know exactly whether it'll be in the form of a book or in the form of documentation and things like that, but we really like working in the Rust ecosystem, and I can only see us shipping a product that meets the sort of expectations that already exist in the Rust ecosystem around this. And this is something that I think can be a really positive improvement, because in the safety critical industry, it can sometimes be really hard to find information on what does functional safety mean and how does it apply to me in the automotive or the avionics industry. So I really hope that we can have a positive impact there and start bringing some of the Rust culture of documentation and teaching to these industries as well, and make it easier for people who have never done safety critical systems to really feel at home writing safety critical systems in Rust, or at least to start understanding the language perspective of writing safety critical systems in Rust.
Thank you. This brings us to the next question. Name companies that have been successful with Rust.
So this is where one of those really interesting things where Rust started out its life not necessarily as a safety critical language or even as a purely embedded language. There had always been the idea to support embedded systems as a platform, and an idea to eventually support people in industries like safety critical systems, which means that users outside of embedded systems and outside of safety critical systems have been successfully using Rust pretty much since the 1.0 version of Rust stable released in 2015. To date, Rust has a wide variety of companies who have spoken publicly about their use of Rust, not necessarily in safety critical systems, but in what we would call at Critical Section mission critical systems, systems that have a high expectation of reliability, or they may be, for example, business critical systems where a huge amount of money is relying on them. Whether these software systems that are written in Rust are part of critical network infrastructure or part of critical products to different businesses, a huge number of companies have talked publicly about their use of Rust and typically the very successful experience that they've had there. Now, this doesn't always translate one-to-one to safety critical systems because we are working in somewhat different domains. However, we can certainly take inspiration from their successes and the things that they learned operationally throughout this time, in that their understanding of how it works to develop Rust and how it works to integrate Rust into their pipelines, whether that's on pure Rust projects or projects that are integrating with languages like C or C++ in these environments. We can definitely learn a lot about the lessons that they learned. And these companies that I'm talking about are generally the most widely used internet companies out there in the world. There have been conversations from Microsoft or Amazon or Google talking about how they use Rust in practice and what kind of successes they've had and what kind of reliability that they found and expect from Rust. And I think these are companies that we can really look to from the embedded industry as having the best of techniques for the safety critical industry. So I find that embedded systems tends to sit right in between sort of two sister engineering disciplines. And that's the more classical electrical and mechanical engineering industries, which have much more formal process, are used to things like, ISO specifications and things like that, where there's a wealth of understanding and engineering knowledge that in embedded systems we need to draw from when we're shipping safety critical embedded systems. However, embedded systems also draw from its other sister engineering discipline, which is software engineering, which is developing software at a really large scale and designing and architecting and implementing software with good architecture and testing and continuous deployment practices in mind. And I think we can learn a lot in the embedded industry from how folks in our sister industries like software engineering at the large for scales of companies like Microsoft or Google or Amazon use in terms of best practices as they're developing and owning software over the life cycle of the entire software development process. So we can already draw some data points from our software engineering friends, and then we need to make sure that we help deliver on those more classical engineering disciplines as part of the Ferrous efforts to make sure that we're working on that. So the answer is there are a lot of companies that are very successfully using Rust, and there are already success stories of companies successfully using embedded Rust in practice, whether that's for laboratory equipment for things like quantum computer analysis. So I know there's a company based in a couple places who are building laboratory test equipment for measuring quantum computing experiments and things like that, and doing things like data acquisition and capture and analysis and things like that. As well as people who are working a little bit more quietly on consumer products and shipping consumer products for Rust, whether that's connected wireless devices or whether that's low power sensors and things like that. Unfortunately, the embedded industry talks much less widely than the software development industry about the tools that they use and the successes that they have. I hope that does change in the upcoming years, but we're starting to see these success stories on the embedded side as well, and we have this sort of wealth of 6 years of operational experience and success stories from other people using Rust outside of the embedded industry, which I think we can really draw from, at least for part of the reliability expectations there.
Thank you. Next quick question. Will Rust supersede C and C++ in embedded systems? Pretty direct.
That's a direct question, and I hear this a lot, so I think it's a really good one to answer. And the answer is sorta. It depends on how you look at it. I think even if Rust was wildly successful, C and C++ are not going away today, in 10 years, in 20 years. I really don't think they will. There's millions or billions of lines of C and C++ code out there that is running every day and is continuing to be used, and lots of it is very well tested and has lots of understanding and effort put into making sure that people can understand and verify the sort of work that it does. And that code's not going away anytime soon. I won't say will never be going away, but probably not in my career. That code will not be going away, certainly not entirely. You can see this with languages like COBOL or Fortran or things like that. For the areas that they are serving, they continue to be maintained because it doesn't make sense to rewrite those systems from scratch. It really doesn't, because you've already put that amount of work and verification into it, and you have that level of understanding. However, where I will see is, I think over the next years, Rust will start to replace C and C++ as the first language of choice for new projects, for greenfield projects, or greenfield libraries or greenfield components. I can see Rust being a really excellent choice where if you are starting from a blank working space, that why not start with Rust if it has better tooling and it has better things like that, and you're not gaining the experience? Or if you can say, well, the fundamental part of Rust, the fundamental part of the project will be in Rust, but we're going to still reuse some of our C components because they might be a network stack that we have a lot of faith and has had historically a really high level of quality. However, if you start asking your engineers of those libraries that you've been using for 5 or 10 years, whether they always are predictable and they always are well tested and they really do behave the way that you expect them to, or whether you continually have new vulnerabilities and bugs that you find every 3 months or every 6 months, you might want to be careful about how much value you put towards the pieces that you already use. I will very rarely recommend rewriting a new system or rewriting a system from scratch in Rust just to do it. Very, very rarely does that work out well just because it's a challenging problem, especially for those projects where you have a lot of those implicit requirements encoded into the code itself, where no one really knows what it's supposed to do other than what the code does right now. And those code bases are basically impossible to rewrite because you end up rewriting them one for one of what they were. However, for projects, like I said, where you can start from scratch, or there's really well documented expectations of what that code is supposed to be doing, or there's a lot of tests for what that code is supposed to be doing, there's always a somewhat incremental approach you can take to Rust. And I think there's always going to be that very engineering answer of it depends, in that maybe it doesn't make sense for your company this year. But if you were starting a brand new project that, like our previous question, was supposed to last for 10 years, and maybe there was 1 or 2 holdout dependencies, you might be surprised how quickly those could be implemented for at least the parts you need in Rust, and you don't have to worry about that, and you feel like you've set yourself up on a good foundation for the next 10 or 20 or 30 years. So my answer is yes, but also no. But it's going to be the very boring engineer answer of it depends. But I think it really could replace it for new designs in the near future. And then in the 5 or 10-year design life cycle space, it might replace it as the default, or you really have to make a justification if you do want to go back and write a project in C or C++ versus Rust.
Thank you. So last question on stream. We may continue answering on chat. For formal verification, is the plan to stick within the bounds of the Rust type system or shell out to something else that offers more powerful facilities for extraction, such as higher kinded types?
So I admit you have the two wrong people in this chat, because we have another wonderful expert at Critical Section whose name is Sabri, and he is absolutely the right person to ask this question to. I will give a somewhat limited answer, but I'd love to follow up. So if you know how to get in contact with me, if you could send me your information, or if Florian could drop if Florian wants to answer this question, I will admit that my background is not in formal verification, but rather more the safety critical application side. But I think Florian's been talking with Sabri much more than I have. So I'll let him answer this question for us.
Well, first of all, yes, Sabri is the person to talk to, but I have some insight into that topic. One part of it is the debate around higher kind of types in Rust. GATs are coming at some point, which are kind of similar to higher kind of types. One thing that we would like to invest time on is particularly finishing open gaps in the type system on Rust itself. So we prefer to finish work that's already started on Rust, except we prefer that over touching additional tooling. That being said, there's already a huge amount of tooling around Rust, particularly in the formal verification space out there. If you check what universities are doing, particularly ETH Zurich or the University of Saarbrücken, and all those basically do what you described. So the path of putting additional tooling on top of Rust that rely on the base semantics of Rust is definitely there. But all of this tooling can be solidified by the effort that we're making of making Rust in itself as a basis better understood. So that's our first order goal. We would like to work on Rust directly first before we start working on any kind of those things. And if in any way possible, we would also like to solve these problems on the language or on the core tooling level if possible. There's a certain amount of space where it's not quite sure whether something should be touched on at a language level or at a core tooling level, particularly for the reason that all of the things that are out there in research currently differ substantially in their scope and in their approach, and this is good. And there's a balance to be taken here. I think this whole thing could actually merit a whole Q&A session in and by itself, so I can imagine that coming up in the future.
Yeah. All right. Well, we are getting close to the end of the hour, and I know Florian does need to run, unfortunately. So I'm going to say goodbye to Florian for now, and I will stick around and I will do some lightning questions. So if you have any questions, now is your absolute last chance. I will go down and give quick answers to any questions that are in the chat, and then I will probably wrap up. But thank you, Florian, for being here with me today, and looking forward to chatting with you soon.
Thank you.
All right, so I have 2 questions left in the chat, and I will answer those. But like I said, you have another minute or 2 to get your questions in before I will wrap up the stream. Okay, someone was asking, do I bet SpaceX will start using Rust in rocket software? I wouldn't be surprised. You know, I can't always say who we've been talking to in the past, but there are certainly companies already using using Rust in a space capacity. So there's a company called Kubos in the US, Kubos, that is already using it for a communications and management platform that they are already deploying. I believe it's already deployed on satellites that are out there. So I can see it coming down the pipeline. There's a variety of different safety critical and non-safety critical technologies that go into any assembly, like a rocket ship, where there will be some that are highly safety critical and some that are not, and some that are on manned missions or some that are on unmanned missions. So I think it's definitely a possibility for the future. So I wouldn't worry about it too much. I could definitely see it coming down the pipeline. There's another question that is, a lot of safety critical systems that I've seen are running on targets that are not tier 1. In my opinion, this might be an issue for adoption in these systems. Do you plan to address this? So, as a bit of background information, Rust has what it calls platform tiers. So it has different support levels for different combinations of CPUs and running environments that you might have. So, for example, x86 64 on Linux might be a tier 1 target. And what a tier 1 target means is that there are compiler tests for all of these things, which means no change happens to the language that would potentially break support on these platforms. This means code will compile, programs will run, and things will work as expected. So most of the common desktop targets, like Windows, Mac, and Linux for most modern systems, fall under this tier 1 target. Tier 2 targets means that there are some tests and that some code artifacts are built. However, there may not be sufficient testing to make sure that every bug that could be caught during testing would be prevented from going out. And then tier 3 systems are other ones where someone has said that Rust does work with this, and there may be some limited support in the upstream project. However, it's not necessarily guaranteed that it wouldn't break over time. The nice thing about this is the Rust project can focus its efforts on a limited number of items. So the Rust project is an open source project, which means there are a limited number of volunteer hours that can go into supporting these platforms. Too many means that they will be forced to support platforms that may not affect that many people. Not enough means that they're not really applicable to a lot of people. Now, recently we've seen ARM work to get some of the ARM targets. So ARM actually contributed efforts and resources towards getting some of the ARM targets up to a tier 1 platform, which is a really great thing to see. And there was a result of quite a bit of effort on their side as well as on the Rust project side. However, I think this sets a really good stage of, if we have communities or manufacturers like ARM or folks in the RISC-V space, it is definitely possible to move a target up to tier 1. And really the limiting factor here is time and effort and resources. So I think there's definitely possibility to move targets, whether that was a RISC-V target or even a target, a PowerPC target, where if there was a desire to have these up at a tier 1 target, that's definitely something that could be done if there were enough interest in it. And Critical Section or Ferrous Systems would definitely be someone who would be happy to work with you on that, or to connect you to the right people to make sure that this could happen if it's something that's a requirement for your business. So definitely it's something that really just comes down to, has there been enough commercial interest for it? And the answer is, with enough commercial interest, we could get pretty much any of those targets up to a tier 1 target. So if you are a company who's interested in that, feel free to reach out. What role does the embedded HAL project play for Ferrocene? So I mentioned before that embedded Rust allows you to write drivers and components and things like that in a really portable way, in a way that's really challenging to do in other languages. Most of this is built around a set of abstractions called embedded HAL. And embedded HAL are a separation of the definition of certain protocols and functionalities, like a UART or a serial port, or an SPI port, or digital pins or analog pins, or even more complex protocols like network protocols and things like that, that allow you to say, hey, this driver requires some way to speak over an SPI port or a UART port or things like that. And on the other side, you can have support for individual platforms like a Nordic NRF52 or an STM32 or an NXP IMX RT chip that say, hey, I have a serial port and I can implement those interfaces, which means you can, instead of writing a serial port or let's say a temperature driver that you have to port to every single chip that you use, instead you can write the serial port driver, or you can write the serial port abstraction, write a sensor driver that just relies on that serial port abstraction, and write a driver for all of these different families of chips, and it will work out of the box with just a recompilation. The really cool thing is we can extend this beyond just embedded targets, and we can take this to things like embedded Linux targets, or even for desktop Linux systems across things like USB to UART adapters. Because these drivers have been written just to understand the bare minimum of what they require, they can be used portably across all of these targets. Now, I don't know what role embedded HAL will fit into Ferrous. However, we would love to have portability be a milestone of these safety critical industries. So if we find customers who want to begin qualifying libraries based on embedded HAL or based on embedded HAL based drivers, I could definitely see us including that in those infrastructural level items where it's possible to do this kind of validation and specification to make versions of embedded HAL viable for use in these different industries. So I wouldn't look at it too differently from any other driver or crate or library that you might find in the Rust ecosystem. But I think it could be a really cool key way of having these same sort of nice benefits that we gain in the embedded Rust ecosystem in the safety critical Rust ecosystem as well. Whether those are the same sort of interfaces or a compatible set of interfaces with those, I could definitely see it working in either of those ways. So it's definitely something that we think we could keep an eye out and could be an improvement, which could also allow you to more seamlessly switch between safety critical and non-safety critical versions of Rust depending on your market and needs. Now, I have exhausted the number of questions in chat, and I have exhausted my speaking voice for today. So I want to thank everyone who joined us. We did start a little bit early today. Once we finish this recording, it will be immediately live at the same URL. So feel free to start back at where we started on the questions that started beforehand. And you'll be able to watch this for as long as you like. We will be editing these down these questions into individual segments later so that they're more easy to share. But this long form recording will be available from now on. So feel free to share those. Feel free to share this video with anyone who has questions around Rust. And after I sign out here, I will put our contact information on the video here, so you know how to share that. And feel free to reach out to us. If you're at Embedded World this week, feel free to schedule a time to chat with Florian or myself. We will be available all week to chat, or feel free to reach out to us over email, and we are happy to schedule something over email. So thank you again, everyone, for watching, and hopefully we will talk to you again sometime soon.